All right, so in 4.1b, we're going to talk about using operations with radicals. So that means adding, subtracting, multiplying, and dividing. So I want you guys to start with this exploration. You're going to decide if the following statements are true or false. If they're true, give an example to show that they're true. If they're false, you're going to give a counterexample. And a counterexample is an example that proves a statement is not true. So I'm going to do the first one. So in general, is the square root of a plus the square root of b equal to the square root of a plus b? So we can just do an example to find out. So let's say we do the square root of 9 plus the square root of 16. Okay, and so we want to find out if that's the same as if we add them under the square root. So the square root of 9 is 3. The square root of 16 is 4. 9 plus 16 is 25. Then over here we have 3 plus 4, that is 7. And the square root of 25 is 5. So that means that these are not equal to each other. So this is false. Okay, so I want you to go through the rest of them, 2, 3, and 4, decide if they're true or false, and then pause your video and decide, and then you can press play and I will tell you the answers. All right, so number 2 is true, number 3 is false, number 4 is true. So make sure you come up with some examples that prove them true or false. All right, so now we're going to do operations with radicals. So if we were simplifying 3x plus 2y plus 5x, how would we do that? Well, we would combine our like terms, right? 3x plus 5x would be 8x. Then we'd have plus 2y, because that one doesn't have any like terms. Now, based on that example, how would we simplify 3 square root of 2 plus 2 root 7 plus 5 root 2? Well, if we're basing it on that example, we have our like terms, right? These both have a square root of 2. So we have 3 plus 5 would be 8 root 2. And then our root 7 doesn't have a like term, so that will stay by itself. So when you're adding and subtracting radicals, you're going to combine like terms or like radicals. You should also make sure to simplify before you combine your radicals. That way you can make sure that you're in your simplest form. So let's do a couple examples. So for number 1, we simplify 7 root 3 plus 4 root 2 plus 2 root 3. Now first we need to check if we can simplify any of these. So can root 3 or root 2 simplify at all? No, so that means they're simplified all the way already. So now we're going to go and combine our like terms. So here we have 7 root 3 and we have 2 root 3. So that means total we have 9 root 3s. And then our 4 root 2 doesn't have any like radicals, so that one's just going to stay 4 root 2. And that would be your answer for number 1. Okay, now let's look at number 2. So again, we need to see if they're simplified all the way. So we have root 7 and root 11 in this one. Can we simplify those anymore? No. 11 and 7 are prime numbers, so they can't be broken down anymore. So we're just going to look for like terms again. So we have 5 root 7 and negative 8 root 7. So 5 take away 8, that means we have negative 3 root 7s. And then our root 11 doesn't have a like term, so that just stays as root 11. Okay, let's look at number 3. So for number 3, we have root 5, 10 root 5 plus root 20. Now, can we break down root 5 at all? No, that's a prime number, but what about 20? Well, for 20, we could say that's 4 times 5. And then 4 is 2 times 2. And 2 and 5, those won't break down anymore. So we have one group of 2s. So that means we can pull a 2 out front. And then our 5 is going to stay under the radical. And we have plus our 10 root 5 as well. So now, this is why we need to simplify first, because now we have like terms, right? We have 10 root 5 plus 2 root 5. So that's going to be 12 root 5. And that'll be your answer for number 3. Okay, and number 4. So for this one, we have the cubed root of 3 minus the cubed root of 81 minus the square root of 3 plus 2 cubed root of 3 plus 5 root 3. So again, we're looking for like terms. So we have our root 3's and cubed root of 3's. Those are all simplified down as far as they can go. But what about the cubed root of 81? To get 81, we could do 9 times 9. And then to get 9, 3 times 3. Okay, and since we're doing a cubed root, that means we're looking for groups of 3. So we have one group of 3 3's to pull on the outside. And then 1 3 is going to stay underneath. So let's fill in the rest of these. 2 cubed root of 3. Okay, so now we need to look for like terms. So here we have 1 cubed root of 3 minus 3 cubed root of 3. And we also have plus 2 cubed root of 3. So 1 minus 3 is going to be negative 2. Plus 2 is actually going to be 0. So we're not going to have any cubed root of 3's left. They're all going to cancel out. And then for our square root of 3's, we have minus square root of 3 plus 5 root 3. So negative 1 plus 5 is going to be 4 root 3. And that will be your answer for number 4. Okay, so try these monitoring progress questions. In the next video, I will give you the answers.